everybody, thanks for joining me. This is Parker from TestPrepChampions.com, and in this video I want to cover volume and what you need to know to get volume questions right on the GED test. So I want to start off with a brief explanation of the difference between volume and area. So simply put, a volume is a measure of the space inside of a 3D object like a cube, and area is a measure of the space in a 2D object like a square. So volume, think 3D, area, think 2D. If you're taking notes here, you'll definitely want to put this down in your notes here. These are some basic facts that you should know about volume. They're not going to be super important for problem solving, but you should understand the concepts here. So firstly, note that volume is also called capacity. Okay, so most commonly you're going to see it as volume, but just know that if you see the word capacity, remember that that is volume. So volume is also known as capacity. And number two, as I've already said, volume is a measure of the space inside of a 3D object. So as a definition, volume is the measure of the space in a 3D object. And also note number three here that volume is measured in cubic units. Now this is different from area. Remember, area was measured in square units. Okay, so volume is different from area because it's measured in cubic units. Alright, so these are the basics that I want you to know about volume, and so now let's look at 2 points that are going to really help you with your problem solving. Okay, so here's what you need to know to solve volume problems, and so don't worry, we're going to go over examples with multiple different objects, that'll really clarify what I'm talking about here, but these are the concepts. So let's do the understanding first, and then we'll look at the problem second here. So basically, the main strategy whenever you have a volume question is to identify what kind of object it is. This might even be given to you in the question, like is it a rectangular prism, a cylinder, a cube? So you want to figure that out first, and like I said, this will often be given to you in the question, and then you'll want to find the formula. So you go to your formula sheet, find the formula, and ideally you'll just plug the numbers into the formula and you'll do the calculation and get the answer. So that's always the first strategy here, but you also need to understand some important concepts. So point two here is that when an object has two identical and parallel faces, either of these can be called the base. Okay, so when the object has two identical and parallel faces, either can be called the base. So let me pull up a big picture here to show you what I mean. Alright, so this is a soup can, obviously. And so a soup can is a perfect example of this. Alright, and so think about the soup can, like imagine it without this little tab on top or whatever you call it, the thing that you use to open it. Same with a soda can. Okay, imagine that that's not there, right? And if we imagine that this little tab thing isn't there, alright, we can say that the top of the soup can, and if you flipped it upside down the bottom of the soup can, we would say that these are two identical and parallel faces. So a soup can has two identical and parallel faces. Alright, a soda can also has two identical and parallel faces. Another common example would be a box, like it could be a box of cereal or even a box of oatmeal. These are objects that have at least two identical and parallel faces, and so when you have one of these objects, like a soup can or a cylinder that has two identical and parallel faces, note that either base can be used in the calculation. So you could use the base on the top here, or you can use the base down below. Doesn't really matter, they're both going to give you the same answer. You just use one, you don't use two. Okay, let me clear this out of the road here. And so that was the second point here. And the third point is that third point follows from the second point here. So when you have an object that has two identical and parallel faces, okay, you want to get the volume, you multiply the area of one of the bases by the height of the object. Okay, so now let's go through and let's look at some examples, but just keep these points in mind because these are key for the problem solving. So the first object that I want to look at is the rectangular prism, also called a cuboid. So you see the rectangular prism on the screen. I'm going to just call it the rectangular prism because that's what it's commonly known as, but it's also called a cuboid, so keep that in mind here. And so I'm going to start off by giving you the formula, but it's not overly helpful unless we know what we're doing. So the volume of the rectangular prism is equal to the area of the base times the height. Okay, and so do you see this word here, rectangular? Alright, that's very important because if you look closely at the rectangular prism, alright, you're going to see a rectangle, and I'm going to trace the rectangle out here so hopefully you can see it more clearly. So hopefully you see the rectangle here. Alright, and so basically what we want to do is we want to take the area of that rectangle and then we multiply by the height, and we have the volume of a rectangular prism. So the area of a rectangle is equal to the length times the width. And I'm going to represent the length with the cursive L and the width with a W here. So let me label the size here. So this is our length, this is our width. And so lastly, we want to label the height of the rectangular prism. So this is the most important part of the process here of finding the volume of a rectangular prism, is identifying the length, the width, and the height. Okay, so now that we know that the formula for the area of the base is length times width, we can actually rewrite this formula here. So we can rewrite it so that we have the volume of the rectangular prism is equal to the length times the width times the height. And again, since we know that the area of the base is equal to the length times the width, we can just rewrite the equation. Instead of putting the b in, we can just substitute the L and the W. So that's why we have the volume of the rectangular prism is equal to the length times the width times the height. All right, and so let me put some numbers to this, and we can try a practice problem here. So let's say the length is 2, and the width is 1, and the height is, let's say, 3. And on a problem on your test, they would give you, you'd be working in units, maybe inches or feet, something like that, but we're not going to concern ourselves with that. Let's just get the basics down here for right now. So go ahead and pause the video. Given these values, try to find the rectangular prism volume. Okay, so let's go over this. So basically, all we're going to do is just what many people call a plug and chug problem. You just find the length, which is 2, and you find the width, which is 1, and I'm using little dots here to represent multiplication, and we find the height, which is 3. And so we're just going to just put this in your calculator. You don't even need a calculator, just do it in your head. 2 times 1 is 2, times another 3 is 6. Okay, and again, if they gave us units like inches or feet, it would be the answer would be in cubic units. So like, cubic inches, cubic feet. And so basically what I did here was, you take this length, and everywhere you see an L in the formula, you put a 2 in, and where you see a W, you put a 1 in, and where you see the H, we just put a 3 in. Okay, so that's how you find the volume of a rectangular prism. Okay, let's go over the volume of a cylinder next. So on screen here is a cylinder. Now you can remember what a cylinder looks like by thinking of a soup can, as we saw earlier, or a soda can. So cylinder, soup can, cylinder, soda can. That's how you can remember what it looks like. Now the formula for the volume of a cylinder is volume equals pi r squared h. Now there's a couple things that we need to mention here. So first of all, pi is, if you don't know what it is, it's just a symbol. It just represents a number, and so pi is approximately equal to 3.14. Now, the number pi, really, it's a longer number. It's repeating. It goes on and on, but we don't really care. For our purposes, just remember that pi is 3.14. Okay, and so r is the radius. So the cylinder has 2 circular bases. Okay, and so we can see one of the circular bases here, all right, which I've just highlighted in black. So the radius is just a measure of the distance from the center of the circle to the boundary or the edge of the circle or the circumference, whatever word you want to use. Circumference is a fancier math word for it, but basically the radius is just a measure of the distance from the center of the circle to a point on the edge of the circle. All right. And that's the easiest way, I think, to think about it. And so we've got the height here too. And so they've already labeled that in the picture, but let me reemphasize that. So this portion of the cylinder is your height. All right, and so the last thing that I want to mention here before we look at an example is that this pi r squared is the area of a circle. So let me just reemphasize that here. So if you want to find the area of a circle, I'm going to abbreviate it as A with a little c. So the area of the circle is equal to pi r squared. So what we're doing here is we're getting the volume. So we're essentially taking the area of a circle and we're going to multiply it by the height, and that's how we're getting the volume of the cylinder. All right, so just keep that in mind conceptually here. So now let's look at an example. So let's say that the radius is equal to 2, and let's say that the height is equal to 4. And as always, we're using very simple numbers here. It's just because I want to get the concept, and let's not even worry about the units. So go ahead, try to find the volume of the cylinder with a radius of 2 and a height of 4. Okay, hopefully you had a chance to try that, but if not, that's okay. Let's go over it. So we're just going to use the formula here for the volume of the cylinder. All right, and so we know that r is equal to 2, so we're going to take the 2 and we're going to substitute it into the formula for r, and we're going to take the 4 because we know that 4 is equal to h, and we're going to substitute 4 in for h here. So let's do the math here. So we've got v equals pi, and so we're going to put the 2 in here, right? So we've got 2 squared times 4. And now we can rewrite this because 2 squared is equal to 4. So we essentially will get v equals pi times 4 times 4. Right, pi times 4 times another 4. Okay, and 4 times 4 is just 16. So the answer here is that volume equals 16 pi, and you'll usually see the number written first. You'll usually see it written like 16 pi. They'll just switch the order, so they put the number first. But that's the answer here. So that's very simple. Just know this formula. You don't even have to really know it, because you'll be given it on the test, but just remember how to use it. So pi r squared h, and let's move on now. Let's look at the sphere next. Okay, so now let's talk about the volume of a sphere, and this one I'm going to go over pretty fast because there's not a whole lot to say here. What you see on screen is a sphere. It's just a round 3D object, and we see that the formula is the volume equals 4/3 pi r cubed. So we've got pi again. We see that same symbol that we just saw with the cylinder, and we see the radius, but this time it's not radius squared, it's radius cubed. So let me just give you an example here. Let's just say that the radius is equal to 3, and I'll let you pause the video and try it out on your own. Okay, so let's go over this. So now what we see in the formula here is that we have r cubed. So let me just do that right off the bat here. So r cubed is going to be equal to 3 times 3 times 3. All right, because r is equal to 3, so 3 cubed is 3 times 3 times 3. So 3 times 3 equals 9, times another 3 gives us 27. All right, so r cubed is 27, so let's take that 27 and just plug it into the formula for r cubed. All right, so we now have volume equals 4/3 pi times 27. And so now what we can do, since we've got this 3 down here, we could do 27 divided by 3, which gets us 9. Then we would rewrite this as the volume equals 4 times 9 pi, and I just pulled that pi out of the way here. And so now the answer is going to be 36 pi. All right, so that's pretty simple. So just know that the sphere is a round 3D object. This is what it looks like, and note that this is the formula, and note how to use it. So that's pretty simple. Not a whole lot about the volume of a sphere to know other than how to use that formula. Okay, so let's talk about the volume of a cube next. So here are some basic properties of a cube that I want you to know about. So we've got 6 faces, 12 edges, and 8 vertices in a single cube. Now you're probably wondering, what's a face, what's an edge, what's a vertices? So let me tell you that. So a face is basically a flat portion on the cube. So I'm highlighting right here, or I'm pointing at it at least. I'm pointing at this flat portion that's kind of reddish looking. This is one face on the cube. So if we count up the faces or the flat portions on the cube, we'll get 6. So let's talk about edges next. So an edge is a line segment on a cube. So I'm tracing one of these line segments, aka an edge. So that's one edge. All right, so this is another edge. All right, and so if we count up all the edges, we're going to get 12. So lastly, let's talk about vertices. So first of all, what is a vertex? Well, a vertex in math is a point where 2 or more lines meet. All right, so here I'm going to highlight a single vertex right with a dot. All right, and we see here that multiple line segments or edges, they meet at this one spot, all right, and that point is called a vertex. So we've got one vertex. Now, if we've got multiple vertexes, we would call them vertices. You can also just call them vertexes, whatever works, but I like to say vertices. I think that's more commonly used, but you can say vertexes, doesn't really matter. But we've got 8 vertices in total here. Okay, so now let's look at the formula for the volume of a cube. All right, so the volume formula is edge cubed. Edge cubed. All right, and so really it's pretty simple. You would just, whatever number they give you and they say this is the length of the edge, whether it's 2, 3, 4, so say it's 2, right? So if it's 2, you would just do 2 cubed, and hopefully you know that 2 cubed is equal to, it's not 2 times 3, it's 2 times 2 times 2, which 2 times 2 is 4 times another 2 is 8, okay? Now, so that's kind of our example. We're not really going to look at another example because this is pretty simple, but here's another point that you should note. So you might want to make a note of this if you're taking notes here. So for certain word problems on the GED test, right, they're going to give you that word edge, and just based off of that word edge, you're going to have to know that you're calculating the volume of a cube. So they might talk about like some kind of container, like whether it's a box or a crate, and they'll tell you that the container measures maybe 20 feet along each edge. Okay, or they'll say that people were moving and they put stuff into boxes and the box measured 20 feet along each edge, or a worker was unloading a crate from a truck and the crate measures 10 feet along each edge. Okay, you might get something like this. And so I want you to note that the word edge, okay, if they're telling you that it has the same measure along each edge,
what that means is that you're dealing with a cube, okay? Because as I said, cubes have the same measure along each edge. So that word edge is usually going to indicate that you're going to calculate the volume of the cube. So again, you've got to use common sense and you've got to think about it within the context of the question. But usually that word edge, if they're telling you that this crate or this box, whatever, this container is so many feet along each edge, you're probably dealing with a cube.
Let's talk about pyramids next. So when most people think about pyramids, they picture pyramids in Egypt, like in one of those movies, like The Mummy or The Mummy Returns or The Scorpion King, whatever those movies were. They think of pyramids and they usually have a good picture of what a pyramid looks like in their head. So this is a geometric pyramid that I'm showing you on the screen here. And as you can see here, it's got 4 triangular faces here. I'm pointing to one of the triangular faces. There are 4 of them, and they all meet here at a single point, which is a vertex that we call the apex. And we call it the apex because it's the highest vertex on the figure, and it's also directly opposite of the base. So that's why we call it the apex. So here's what you need to know about pyramids. So basically, the formula for the volume of a pyramid is volume is equal to 1/3 area of the base times the height here. Okay, now let's pay attention to the base, because this B, again, is the area of the base. So what is the base here? Well, let me trace it out here, and you can try to figure out what shape this is just by looking. Hopefully it's pretty easy to see that this is a square. Okay, so the base of a pyramid for our purposes is going to be a square. So on the GED test, it's going to have a square base. Now, it could be a different base in another context, but for the purposes of the GED test, you're going to be given pyramids that only have square bases, so that's all you have to worry about. So the volume, or so the area of a square, right, so I'm just going to put area, little s here so you know I'm talking about the area of a square, is just side squared, right? It's side times side, which is another way of saying side squared. So what we want to do here to solve the problem is we're just going to we have to know the length of one of the sides of the square, and we can do side squared, and then we can substitute side squared into our equation for the B. Alright, so let me just rewrite this now that we know that we can do that. So the volume is equal to 1/3 side squared times height. Okay, so now again, the reason why we can replace that with the side squared is because the formula is volume equals 1/3 the area of the base times the height. And the area of the base is calculated by taking the side of the base and squaring it, or doing side squared. Alright, so all I did was I just took this side squared, which is the area, and I substituted it in for the B into the equation, and then what we have here is the volume equals 1/3 side squared h. So hopefully that makes sense. You guys are really good. I'm sure you guys followed that, but if you need help, as always, just let me know down below and I'd be happy to clarify that. So basically, now what we need to do is, let me give you some numbers here to work with. So let's say that the side is 3. Side length is 3. I mean, it could be centimeters. Let's do centimeters here. Oh, and the last thing is the height. So the height is, like usual, it's probably going to be given to you as a dotted line, so it's going to look something like this. This is your height, and the height is just a straight line that's going to intersect with the base. So it's perpendicular to the base, meaning it's going to cross the base at a 90-degree right angle. So let me just make an H here so you know that that's the height. And for the height, let's not get really that creative. Let's just make the height equal to, let's do 3 again. Okay, so go ahead, let's do that calculation now. Pause the video and try it out on your own. Okay, let's go over it. So the first thing that I want to do here is let's figure out the area of the base. So we know that the area of the base is equal to side squared. In this case, one side of our square is equal to 3, so we would have 3 squared, which is equal to 9. So I'm going to plug that into the formula, so we know that 9 equals our big B, area of the base, or side squared, whatever you want to think of it as. And so now we've got volume is equal to, let me just write this as divided by 3. So multiplying by 1/3 and dividing by 3 are the same thing. That's just however you want to think about it. So we've got 9, which is our area of the base, times 3, which is our height. Alright, and so hopefully you see here that we can just cancel the 3 out of the top and the bottom, which just leaves us with 9. So we've got 9 centimeters cubed All right, and I didn't add that here, but let's imagine that this 3, let me go back in retrospect and say that this height was 3 centimeters, so that would give us 9 centimeters cubed as our answer here. And one last thing I just want to mention very briefly, so remember the formula for the rectangular prism, it's volume equals base times height. Okay, so we note that there's a similarity here, all right, and that's because, so if we had a pyramid and we had a rectangular prism, right, and they both had the same base. Okay, let's say that the base had a side length of 3, okay, on each side, and if we calculated the area of the base for that prism and the area of the base for the pyramid, right, and the area of the base was the same, all right, we could make the following statement about the objects. We could say that the volume of the pyramid is 1/3 that of the volume of the rectangular prism. All right, so that's why the formula of the volume of the pyramid has that 1/3 in it, and the volume of the rectangular prism is just the area of the base times the height, and we don't see that 1/3. All right, so just something to help you with the concept here, but that's not overly important for the GED test. So now let's talk about cones. So what we see here on the screen is a cone, and I'm going to box this cone in so you can see which shape I'm talking about, because right next to it I've got these cylinders here. So hopefully you remember that soda cans are cylindrical, right? So soda cans are cylinders. And I did this to show that there is some similarity, right? So the cylinder has these 2 circular bases, right? It's got one circular base at the top, one circular base at the bottom, and they are identical. And what we see here, though, with the cone is that it also has this cylindrical base. So the cone, if you look at it here at the bottom or at the base, it starts off kind of looking like it's going to be a cylinder, but then the sides just curve in and the sides collapse here and meet at the single point, which is the vertex of the cone. All right, so we see that there is some similarities between the cone and the cylinder, but they're not exactly the same. All right, namely, you could take this cone and you could put it inside of a cylinder. All right, but you cannot take a cylinder and put it inside of a cone. All right, that will not work. All right, and so the reason is because the cone is a little bit bigger than the cylinder, all right? In fact, the volume of the cylinder is 1/3 bigger than the volume of the cone, all right? So let me write out the formula here. So the volume of the cone is 1/3 pi r squared h. Pi r squared h. And so let me just refresh your memory on the volume of the cylinder. So we've got here the volume of the cylinder. So I'm going to write a little CYL to show you I'm talking about volume of the cylinder of this formula. So the volume of the cylinder is equal to pi r squared h. Okay? And so what you'll notice is that the formulas are very similar, except because the volume of the cone is 1/3 that of the volume of the cylinder, we have this 1/3 in front of the pi r squared for the formula for the cone. Okay, so that's what you really need to know here. This is the formula for the volume of the cone, so that's some conceptual understanding of why that is. And so now let's try an example problem, and then we're going to wrap up here. All right, let me clear this formula out of the way for the volume of the cylinder. We don't need this. And so let's just make up some numbers here. Again, let's keep it pretty simple. Let's say that R is equal to 3. R is equal to 3. And let's say that H is equal to 3 as well. All right, so you know what, let's not do that. Let's say that H is equal to 9. All right, so go ahead and pause the video, try this out on your own. Okay, so let's go over this. So we've got V equals 1/3 pi r squared. And so we're going to take our r value, which is the radius, and we're going to substitute it into the equation for r squared. And so we know that r squared, if we take 3 and we square it, which we've seen numerous times in this video, we're going to get 9. So let me just right off the bat replace that with a 9. And so the height here was also equal to 9. So we've got 9 times 9. And we see that we've got this 3 down here, right? So we can take one of these 9s and we're going to divide by 3. So we would then rewrite this as V equals 3 times 9, and I'm just going to pull the pi out of the way here, and 3 times 9 is 27, so the volume would be equal to 27 pi. Alright, so that's pretty simple, just kind of another one of those plug and chugs. You just have to recognize that you're dealing with a cone and recognize the formula. So that's about it. Alright, so thank you so much for watching this video. Please subscribe to my channel, like this video, and I'd really appreciate that. Let me know down below if there's anything you'd like me to clarify. Let me know how your test goes, guys. I'd really love to hear from you. And so just some final thoughts here. The strategy for these problems is always to go and identify what the shape is and then go find a formula for volume, and you've got to remember how to find the area of the base for certain bases, right, like your pyramid and your rectangular prism. And also you're going to watch out for these cones and the cylinders and make sure that you can tell them apart. Make sure you can tell the shapes apart and that you know which formula to use for which, and practice using the formulas with some practice problems and you're going to be good to go. Alright guys, so thanks again. Enjoy the rest of your day.